All right. Good evening, ladies and gentlemen. Welcome very much to our March Recreational Astronomy Night here at York University. My name is Tom Luton. I'm going to be your host this evening. First of all, can I get a quick show of hands? Anyone here new? Anyone here for the first time? Welcome. So this evening we've got several presentations. First off is Denis with the Sky This Month, followed by Frank Dempsey with his current visual observing projects. We'll wrap things up with Jeff Booth and Tony Horvatin with the Aurora Borealis, a mesmerizing natural wonder. And then to final things off will be our President Scott Masterton with our announcements. Right, so Denis, if you wouldn't mind.
Sure. Thank you, Tom, and thank you, everybody. Good to be back again. I haven't had a chance to do one of these in a while, so I'll be looking forward to seeing what we were able to figure out about the month. So we're looking at the month of March. As usual, we'll talk a little bit about the big picture. Some of the highlights are here. Not much to report this month on comets or asteroids. But note that it is Messier Marathon season. I know the center had been talking a little bit about running a Messier Marathon this year. I don't know if we got that scheduled. End of the month. It's coming end of the month. So that's something to keep in mind. And hopefully we'll have some questions and answers. So as I usually like to do, I like to sort of start off with what I call the big picture. And this is an all sky map that sort of shows you everything that's going on. And one of the big things that's been sort of highlighted in the news of late is planets on parade. So we have planets, all of the planets basically on one side of the sun relative to Earth. You can't see it here, but Saturn is kind of right about there, right about behind the sun. And then Venus and Mercury are in the evening sky. So I had a chance to see Venus on my way in here tonight, looking very good. And Mercury is heading for its greatest eastern elongation, best seeing of the year on March 18th. So keep your eye open for the two of them, and they will be passing quite close to one another as Venus is diving down all very quickly now as it's approaching us on the inside track of its orbit, and it's going to come between us and the sun later this month and then emerge into the morning sky by the time this month is over. Following on to that, we have Uranus and Jupiter. And then beautiful Mars is right up there, kind of in one of the prettier parts of the sky. So the winter hexagon is this sort of big asterism here. It's really obvious in the middle of winter, but as we were sort of heading out of winter now it's starting to be in the west. But you see it as a sort of the brightest star, Capella, Castor and Pollux, Procyon. You've got Sirius there, Rigel, and then, of course, Aldebaran. So those six stars together make this hexagonal shape, and it is kind of the big star pattern of the winter season. And then, but what's really kind of coming up to the fore now after, say, 9 or 10 o'clock at night is the spring constellations, particularly Leo with that backwards question mark, and the triangle rump on the lion there, and then Virgo, the Virgin, which is not a particularly bright or standoutish constellation, but has a lot of beautiful galaxies that you can find there. So galaxy season is upon us again, and we're getting into that season now because of where we are in the galaxy and where we are, where our night side of the Earth is facing. This is also something I like to show all the time is the yearly sun graph. So right now we're heading towards a discontinuity here where there will be an earth-shaking event this weekend. And that earth-shaking event is the advent of daylight savings time. So everything shifts an hour. Fortunately, most of us are in our beds, but when that shaking comes, you'll notice that there. But as you can see, we're heading into the season, and what you can't really see in this picture as well is how the time change at this time of year is actually very rapid. It's not your imagination. We're gaining about a minute of daylight on either side, both in the morning and the evening every day. right now as we get closer and closer to the equinox. At the moment of the equinox is the time when the rate of change is its highest. And then when we're in the solstice, either in the summer or the winter, that's when the rate of change is at its slowest. And the spring equinox is coming up this year on the 20th of March. So not the 21st, it's actually the 20th, 5:01 a.m. in the morning. So when you wake up on the 20th, it'll already be spring. And this was what I was referring to about galaxy season. So one of the things that makes galaxies easier to see and easier to find is when we're not trying to look through the Milky Way to look outside into intergalactic space. So during the spring, we're looking up north of the Milky Way. The Milky Way is kind of on the horizon, and straight above us, we're looking straight out into intergalactic space, which makes all of those galaxies that are there much easier to find. And at the same time, it means that there's less other goodies in the sky besides that, because all the bright stars, all the star clusters and so on tend to be in the Milky Way, band of the Milky Way. So that's why in the summer you see all those pretty star clusters, because then we're looking at the center of our galaxy and you're going to see a lot more stuff that way. But for now, it's time to focus on those galaxies. Looking west at sunset, we're starting to see some of our favorites from the fall starting to head down. So we have M31, M33 highlights in the fall. I always look forward to seeing them come back. They're starting to get into the muck now. Perseus also starting to get into the muck, although it's pretty close to circumpolar. And M45, the Pleiades and Taurus and everything, they're starting to get down there. But if you stay up all night, as some of us may during the Messier Marathon, and you get up in sunrise, you would see the beginnings of the summer constellations are starting to come there. And the big asterism I always look for is the summer triangle, which is made up of Vega, Deneb, and Altair. And so Deneb in Cygnus, Vega in Lyra, and Altair in Aquila. And those three stars often punch through even in downtown Toronto and make a really nice pattern. So that's what's there for you in the morning. And we'll be looking forward to seeing that as we get closer and closer to the summertime. Now, in the month of March, meteorologically, and I think Frank knows more about this than I do, but we're in a period where we're starting to move out of relatively stable midwinter weather. So as things get calm down, we often get some nice, clear, but extremely cold nights in January and February. Now things are starting to shift again as the daily insolation starts to pick up and the heat starts to pick up, and we're starting to see more unstable weather. So right now the cloud forecast kind of about 60 to 70% on average for this month. It's not as good as September when we have some of our best weather and our best weather prospects, but there are some good nights there. So the message is, as always, if it's clear, you should go out, because when will it be clear again? You never know. So let's look at this month sort of week by week here. So this week, starting tonight, we've got a few highlights. So the greatest elongation is when the planet Mercury is the furthest apparent distance from the sun. That's this weekend on the 8th. And the moon will be at its closest with Mars, 1.5 degrees away, which is really close. That's like a moon and a half's distance from Mars. So that's actually kind of a nice potential photographic, but certainly worth having a look for it, because it's going to be near Castor and Pollux in Gemini. So you have two bright stars, the planet Mars and the moon, all together on the 8th. And then on the 10th, Mars is going to reach a point in its orbit where it's actually, as seen from the solar system, it's at the most northern point in its orbit. One of the reasons why this particular Mars apparition has been really good is because it's been very high in the north. So as you're watching it go over, we're looking straight up, so we're able to see through the minimum amount of atmosphere. So Mars has looked better in telescopes than it would usually. So that particular milestone is happening on the 10th. And then on the 11th, we've got a double shadow transit on Jupiter. which is always nice. So there's a couple of those this month, so you might want to make a note of that as well. Jupiter's always worth checking. On the 12th, we have another close encounter with a bright star. That's Regulus. That's in the constellation of Leo, so the moon will get close to that. A total lunar eclipse, which we're going to talk about in a minute, on the 14th, which is looking forward. And then the zodiacal light season begins for the in the eastern or in the evening sky. So the zodiacal light, for those of you who haven't heard of it, is basically all of the dust that's left around in the solar system between the planets and asteroids. There's dust that's spat off by comets and little bits of asteroid bits and so forth. And that combined dust creates a little glow that you can see when the sun is hitting it and reflecting it right back at us. So it's kind of like it's at its best. It's always there, but it's at its best for 2 weeks in the spring and 2 weeks in the fall. And we're heading into that season. So in order to see it, you need a really dark sight, a nice clear horizon, and no or very little lunar interference. So that's towards the end of the month you will see it, but the season starts around the middle of March. So the lunar eclipse. How many people are planning to see the lunar eclipse this year? 1, 2, 3, 4. Come on. Everybody should be looking for the lunar eclipse. So this is actually one of those things where I was going, oh my gosh, this is fantastic. What a great public education opportunity. We're going to get out there. We're going to get telescopes. We're going to have everything there. What time is it happening? 2:58 a.m. Oh, well, maybe that's more of a do-it-yourself kind of event, perhaps. And that's what it looks like. But I've got a really good total eclipse. We've got a lot, really nice maximum phase. And the nice thing about the lunar eclipse is it's perfect for a winter's night because if you've seen one before, they unfold in a very stately, majestic, and slow way. Unlike the frantic path of getting a solar eclipse done. You've only got 4 minutes. Oh my God, oh my God, oh my God. This takes all that time, and you can go in, get hot chocolate, have a glass of wine, whatever you want, kind of thing. So, and also, as you can see here, the altitude is pretty reasonable. So it's not going to be, right down by the horizon. We're not worried about that. So it's going to be fairly high up. That's a blessing and a curse. So the blessing is it's easier to see and to find. The curse is if you want to take a picture, then you're just kind of taking a picture of the moon by itself. It's hard to get something interesting in your photograph in the foreground. So it's one of those things where it's a little bit of this and a little bit of that. Now, timeanddate.com has this awesome animation which they have for every eclipse. And this is what it's going to look at. So on the night, we have the eclipse begins with the penumbral phase, and the penumbral phase is hard to see. When it's near this point here, you can start to see there's a little bit of something going on this end of the moon, and you can see that the bite is going to come on the side that's opposite Mare Crisium. That's the way that these things usually go. So Oceanus Procellarum over here will get it first, but as it continues, the Earth's umbra, which is the actual core of our shadow, starts right around that time, and then you really notice it here. So this is when you actually see the moon starting to, I'll back it up a little bit more here. Come on. So at around here, you see this bite taken out of the moon, and it's pretty obvious. And then about halfway through, the Earth shine starts to punch through, and you start to see the moon going more and more red as it comes into the Earth's shadow. And eventually that little piece disappears, and then you have the entire moon in that red shadow. And as the moon passes through that shadow, where it's passing through sort of the northern point, so this edge will be darker than this edge, and then you'll see it kind of getting glowing again as it reaches that point, and then emerges into it, at which point in time you'll probably be already in bed. But nevertheless, if you are staying up for it, we can see the whole thing here from Toronto. So it's going to be quite the show, weather permitting, as usual. So this is a nice eclipse. Everything about it is great except for the time. Other than that, it's perfect. So can't have it all, unfortunately. Where is it going to be in terms of what else is behind it? So when you have totality for an eclipse, one of the things that happens is everything that's behind the moon, which is kind of washed out when it's full, will punch through and punch up. It'll become, because the moon is dimmed by like a factor of 20 or 50 or something like that. So all of the stars and everything behind it will emerge. Now, the part of the sky that the moon is actually in is actually kind of devoid of really interesting stuff. There are some galaxies, some SA galaxies and so forth around there. So a wide field shot might pull some of those in, but it's not ideal. I wouldn't call that a super duper opportunity. So I won't be too upset if I don't get something there. So after the eclipse, we get back to sort of business as usual. So the eclipse is happening at the point of full moon. And so now the moon is starting to wane. So we get another double shadow transit on the 20th or the 19th, spring equinox on the 20th. And the moon almost touches Sagittarius on the 22nd. And this is a bit of an interesting thing because the moon has, it follows the plane of the ecliptic, but it can go 5 degrees above the ecliptic and 5 degrees below the ecliptic, depending on where it is in its elliptical orbit and where we are in our elliptical orbit and everything else like that. But there's a theoretical southernmost point, which if you put everything together, the moon can get this far south at the absolute maximum, and it's actually going to hit that around March 22nd. So if you happen to be looking at the moon in the morning of March 22nd, you will see that it's almost touching the Sagittarius teapot, which is very, very close to the southern horizon for most of us here in Canada. So that's kind of a cool thing. And then on March 23rd, Venus is going to be going through what's called inferior conjunction, which means that it's directly between us and the sun. It's going to be, unlike what happened in 2004 and 2012, right? We won't have a transit of Venus because Venus is going to miss the sun. It's going to dive below it. But that means that it's going to be then emerge into the morning sun after that. And then the other thing that's kind of interesting that's happening on the 23rd is that we're actually going to pass through the ring plane of Saturn. So one of the things that I've been mentioning is double transit, shadow transits on Jupiter, which happen frequently because Jupiter's ring plane or the plane of Jupiter's satellites is the same as ours. Saturn, those beautiful rings that show on that funny angle, they only line up with us once every 13 years or so. Now, unfortunately, it's on the wrong side of the sun. But right now, and when Saturn emerges in this morning sky, in the April-May timeframe, you may be able to see Titan shadow transits on Saturn. So that's something for the next Sky This Month person to look at. I looked for good asteroid occultation opportunities, good comet opportunities, could not find any. The best available is a periodic comet, Watchman. It's 11.6 magnitude right now. It's kind of hanging out near the Beehive and M67. So you may be able to find it. It's close to Leo, so it's kind of there. It looks like that fuzzy spot right about there. So it's faint but reliable, and its magnitude is fairly steady. Every other comet that's visible from Toronto right now is dimmer than that and tending to more dimness as the month goes on. So nothing much to share there. And we get to the final week of the month. The moon and Venus come into conjunctions. So for the second time this month, this time in the morning sky. So on the 27th, there will be this very, very thin moon. Venus will have pulled up from the sun. It'll be in the morning sky now, and the two of them will come together. And on the 29th, when we have new moon, there is a solar eclipse, partial, but it's only visible from the Atlantic provinces. It's literally the sun will not rise before the eclipse is over here. So there you go. And then one of my springtime faves is the moon will be close to the Pleiades in the evening sky on April 1st. A lovely photo opportunity every year. It pretty well has a conjunction or a pulse that's close to that every year. I had a look at transitfinder.com to see if we had any really cool opportunities where the ISS was going to pass in front of the moon or the sun, but not much going on there this year, but keep an eye on that site. And just in terms of the deep sky in March, we'll go through a list of opportunities or things. I think everyone knows that. The biggest opportunity is the Messier Marathon, which I think Tony and Chris are going to talk to later on in the meeting. But that's that special time of year when all of the Messier objects can theoretically be seen in one night's viewing. It's always a bit of a fun thing to see how close you can get to 110. And of course, the galaxies are up there. A lot of Messier objects and a lot of NGC objects, if you're pursuing your certificates, are only available this time of year. So now is a good time to get out there and start to work on it. And just before I open the floor to questions, I just wanted to make a note that it's been 1 year since we lost our good friend Guy Nason. He was a fellow who got me into this astronomy biz and helped me get to know this Toronto Centre and was very welcoming when I first joined. So I'd just like to call him out again and say thanks a lot, Guy. I even had a successful occultation. I did not get nascent earlier this year, and I'll share some stories about that later on. So thank you very much. Any questions?
Yes, any questions from the audience?
Yes, sir.
Hi, thank you very much. Can we please see your slide of the galaxy? I just want to copy down.
Which way is which?
Yeah, which way? There
this
we go.
one,
Oh,
the
right,
viewing
this
angles.
one.
Yes. Yeah, no worries. That's yeah. So just in terms of this, the winter Milky Way, this is where you'll see Orion and those big constellations in the winter Milky Way. In the summer, you would be seeing Scorpius, Sagittarius, and then in the spring, we see Leo, Virgo, those kinds of galaxies, and then in the fall, we see Andromeda and those other ones there. Yeah.
Okay, and I see we have questions online.
There's a question from Eric Briggs. He asks, will the new Blue Ghost spacecraft on the moon see the lunar eclipse?
It will see a total solar eclipse of the Earth, I think, right? So, because it's going to be.
On the moon.
But did I answer that? Did I get that question right? Yeah. No, it should see a total Earth eclipse. Lucky robot.
There's another question, and Ralph Chu answered it, but I thought I would present it to you as well.
Sure.
Denis mentioned the Messier Marathon. Believe he said at the end of this month. Is this something that members can get together to do? I am new to RASC.
Yes, absolutely. So it's being hosted at our club observatory, and all members are welcome. It's obviously one of those things where we need to confirm whether we're going to have reasonable weather prospects. But one of the great things about doing it up at the CAO is there's places to run in and get warm if it's cold. Messier marathons can happen from anywhere from like -10 to +10 degrees, depending on how lucky we get with the weather and if the weather is reasonable. And we do have road access to the observatory this time for the first time ever. So yeah, I think there's going to be announcements about that later in the meeting. And yeah, definitely. What's the dates, Tony? It's the last weekend in March. 29th. Yeah. Yep. So the March 29th. So make a note of that. And there'll be an announcement of a go, no go. It'll be a go, no go kind of announcement based on the weather prospects. And then, yeah, bring your sleeping bag and some coffee bulbs and away you go.
All right, and I believe that's out for questions. So thank you again, Denis.
Okay, thank you.
And we'll just quickly. We're going to switch over to the feed from the Alan I. Carswell Observatory while we get ready for the next presenter. All right, wonderful. And we're back. So next up as our next speaker is Frank Dempsey, who's going to be talking about Frank's current visual observing programs. So Frank, what have you been up to lately?
Okay, thanks. Good question, Tom. So let me start. So the title says it's Frank's observing programs, and that's because it's my personal situation. So anybody else here could do a similar presentation, have their own program of what they do, and it just matches my circumstances. So you see by the title, it's my visual observing program. So this answers Tom's question of what I've been up to for the past few years, and probably the next 10 years if I live that long. And so one of the programs I do is variable stars. So I do this most clear nights. So I'm starting this off with what's the thing that I do most often. And so a couple of charts here give some idea what it's about. T Corona Borealis has been a fairly famous variable star in the past year, with a lot of people waiting for it to erupt as a nova. And then I picked another one, which is called SS Cygni on the right. So I look at these pretty often when I can, but it's basically amounts to recording some numbers. And so here you see my, you okay here? All right, thank you. Just see a bunch of numbers I put into a notebook, and I eventually put them online in a database. And it's not really exciting, not much to holler about. So I'll move on to the next one. So lunar observing is another thing I do a lot of the time, because moon is in the sky quite a lot of the time. And so I showed on the right a couple of sheets. One is a list of the some targets, and I put on one of my observation sheets, and take some time to do it. And I thought what I might do here is because instead of putting up a slide full of text and images, throw in a picture once in a while. So I decided maybe I'll put in a picture of one of the telescopes that I use for these projects. And so here's one of my scopes I use for this project for an 8-inch f10 Newtonian. Does a pretty good job on lunar observing, gives really high magnification. So it's really good. And I thought I'd mention too, in case you detect there's a bit of a homemade flavor to some of these telescope images. Some of them are actually made in Canada. Okay, so I thought I might mention that. Okay, so a couple of images here show a bit more detail about it. The RASC's program is called the Isabel Williamson Lunar Observing Program. It's a really excellent program. It's a lot of targets, a lot of challenging objects in it. And so I've mostly finished it, except for a few challenge objects, which I may never actually see, but it's fun to observe these. And the other program I follow as well is the Astronomical League's program. So I'll be showing a lot of projects that I follow with the Astronomical League, and here's their so-called Lunar 2 observing program, but it's also a list of targets. So I just follow these lists of targets as things to observe, and that's what I do. That's what I find interesting and amusing. Another one is sunspot observing, and here I just picked a picture from a nice government image of some sunspots. Most people know what sunspots looks like anyway, but the result of my observations is just more numbers I put onto a notepad. So I just took an image of my a notepad sheet on the right-hand side there. And in terms of telescopes, the image I chose to illustrate it is my 80 millimeter refractor. So that's a good size for size of a telescope for sunspot observing. So I just pull that out each day, point it toward the sun, and get a quick count of sunspots, and put them in my notebook, and eventually submit them online. And yes, end of that one. But I've been doing this for years, probably decades. So I highly recommend it as one of your projects you might find interesting. Planets is another thing. So I put in a few examples here of planet sketches that I've made. And so these are fairly recent. I started doing this a lot this winter, and we've only had a few clear skies this winter when we've had good planetary viewing conditions. And to get good planetary viewing conditions means we need good seeing conditions. And so the few times that we've had when the sky is clear, most of the time I can point a telescope at Jupiter or Mars and see just a rolling mass of light, and not really a good object. But once in a while, a few rare nights, seeing has actually been pretty good. So I started making sketches. Went on the right-hand side of Jupiter. I decided in this case to try to record the thing that's called the Great Red Spot. And so you see on the left-hand side, it's really fading. So I tried to make a drawing to record what I saw, because I remember this good half a century ago when I built that. You see that telescope on the lower left? That's a 6-inch f10 reflector. And when I built that about half a century ago, great red spot was really distinct and big and red. And now it's fading. I can just barely see it. So it's fine to say, Frank, your eyes are getting old and so on. Yeah, I know, but it's not quite that way. So I know this so-called red spot is really fading into the appearance of the zones on either side of the belt. It's really, really fading. And so I thought, I'll try to actually record the colors that I see. So I went to Staples and bought a set of colored pencils and tried to make this colored sketch you see on the upper right of Jupiter, to try to record this so-called red spot a bit more for my own records of just what I find to be a record of the observation. Similar thing with Mars on the lower right. You may detect some color because in the past couple of months, Mars has got a really nice color. It's a really nice red color with no filters. It really shows up. And this isn't really an excellent apparition, except that, as Denis pointed out, it's nearly overhead. And so there's no dust storms on it yet. So this red color really shines through in any telescope, and including mine. But so I started with just pencil on paper drawings and evolved them to become what I think are little color diagrams, color sketches. Venus is another interesting example because I started to record it. I realized it's, as Denis pointed out, it's zooming down toward the sun, and its phase has been changing noticeably from gibbous toward crescent toward really thin crescent. This one on picture, a little sketch I made on the right, is a couple of nights ago. But I decided what I'm going to do in this coming apparition, which starts at the end of the month with Venus appearing in the morning sky, is use a reticle eyepiece, which is graduated, so I can measure the actual diameter of what I see in the eyepiece. I'm going to make a set of sketches whenever I see Venus of the phase as I see it, as I see it and sketch it, and the diameter. So you see that marked off in the diagram in the lower right-hand side, which is a calendar for the whole year upcoming. So you see that the top upper right shows when Venus is very close to its inferior conjunction later this month, and then appears in the morning sky as a thin crescent and gets smaller in diameter and thicker phase. So I decided I'm going to do this as a sketching project for the rest of this year. I actually did this when I was a teenager, and I thought it's a really interesting way to follow Venus's phases. And so that's what I'm going to do as one of my observing projects. Another one that I've been doing is a lot of deep sky targets. And here's one example, a photocopy from the Observer's Handbook. And so I didn't intend you can see this, but if you're an IARC member and you have the Observer's Handbook, you can just look this up. It's just a photocopy. So it's what I photocopy onto a sheet of paper that I put into a 3-ring binder. That's how I choose to do it. And you see one of my example sketches here on the lower right, and whichever object it is, faint fuzz patch of some sort, that's what it is. So it takes a lot of planning to get these. And here's several sheets of that particular list of objects, deep sky gems, 3 pages. A little over 100 objects. Takes a lot of careful planning to get them all, because some are in the southern sky, some are pretty faint things in the southern spring sky, and if it's too close to moonlight or twilight or polluted light pollution in the southern sky, then it takes some really careful planning to actually get these observations. So that takes some effort. Another one that I want to point out, because it's a sort of fun project, is this open star clusters. And here's another page from Observer's Handbook. I actually did the similar project with the Astronomical League a few years ago, and I decided that was a really fun project, so I'm recommending it. I think that if you have hassle with light pollution and you don't like wasting a lot of time looking for faint galaxies in a light polluted sky, you might like looking for open star clusters. And so as I said, I did this project with the Astronomical League's list a few years ago, and I highly recommend it. So now I'm going to work through this list as I get a chance. Telescope here is a 5-inch Newtonian. It's a wide field. It's a 5-inch f5 Newtonian, so it's a wide field. So it does a really nice job on open star clusters. But I'd have to say any telescope you have will do a nice job with open star clusters. So that's one example. Herschel 400 is another example. It's also an Astronomical League project. 400 objects on this list, and I wasn't going to present it here because I finished it about a year ago. and I thought it was finished. And just in the past couple of weeks when I was putting this together, I thought, here's this binder full of 400 observations on 200 sheets of paper, and why don't I compile it, submit it for the certificate as I can get for it, and pack the binder on the shelf and leave it, forget about it, and get on with the other projects. And so I was doing all this, and I realized, what the heck did I do here? Somehow I didn't get an observation, so I thought it was finished, but I'm not. So I got to do one more. So it's back on my current list of projects to do, because I got to get this one little object in a galaxy in Virgo. So okay, it's now a current project. So I mentioned it's a dark sky requirement, and that means that I got to pack up a vehicle, I got to drive some distance, I got to really plan the night carefully, and it's quite a lot of effort to do this. So I've marked off some of these projects that require dark sky. Here's another example here, and so if you don't want to spend a lot of effort, trouble, freeze your fingers and toes and so on, then you may not want to bother with these ones. But anyway, I'm just listing off what I do as some of my observing projects, and so I'll keep an eye on the time here. But the this is just another example. That's a photocopy from the RASC Observer's Handbook, and I'm going to work through all of these. Some of these are pretty darn faint, so it's going to be quite a challenge. So the telescope here I'm illustrating is 12.5-inch Newtonian. I may have pointed out my C11. Did I back it up there? Yes, that telescope is a C11. And that's a very good telescope, I find, for doing portable deep sky work. C11 can handle all of these objects on the NGC list that are on the Herschel 400 program. They go to as faint as about 12, in some case 13th magnitude. And for border forest skies, that's quite a tall order to get them, but the C11 can handle it. So I find it to be a very good compromise for a reasonable size aperture and a portable telescope that I can handle by myself in the dark. So so some telescopes are a bit bigger. I'm not going to take them on a portable. There's just too much good projects to build a telescope maybe, but not so portable. So here's another one, another photocopy from the Observer's Handbook. It's another good list I'm going to work through. They call it a deep sky selection from year to far. So I'm going to work on that one too. In this case, it's a 10-inch Newtonian, also does a good job. So globular clusters, here's another page from the Observer's Handbook. And the telescope in this case I've selected is a 5-inch or 120 or 127 millimeter, whichever it is, celestron refractor, but does a good job on globular clusters. So it's just another list of objects I'll be looking at whenever. Asterisms is a fun project, so I recommend that if you want something to look in the sky, download this list from the Astronomical League. It's just astroleague.org, and all our observing lists, probably 100 of them, if not more, are free for download. But this is interesting because some are visible by eye, some binoculars, and some telescope. So you might find this interesting. So I've illustrated here a pair of 70 millimeter celestron binoculars, which are fairly common. A lot of people have them. Double stars. So Astronomical League list here again. I list this as one of my current projects. It's almost finished. I've got maybe half a dozen left to finish on the list of approximately 100 stars. You might say, oh, wait a minute, the RSC has a good double star list. It's called the, it may not have been named officially yet as the Blake Nancarroll list of double stars, but I did it a few years ago, did it when it was first introduced. So it was really good, very interesting, fun project to do. From any old backyard, you don't need a dark sky. And here I'm illustrating the 5-inch, or I think it's called 127 millimeter Mac telescope, Cassegrain Mac telescope. So it's a fun little telescope they use for double stars. So are the refractors. But anyway, I finished the RASC list, and now I'm working through the Astronomical League list because double stars are fun. So I think they're a fun project to work through. And as another extension, here's another photocopy from the RASC handbook of colored double stars. So it's also a nice list, and I've illustrated some binoculars on the right. So you could pick any binoculars you have, and any some small ones, big ones, whichever, they ought to do a good job on colored double stars because they are fun to look at in different size instruments. So I find it to be a fun project to do. Okay, so binocular double stars is another list with the Astronomical League, and it's got its own challenges. It's fun to do with binoculars. So here you see again my 70 millimeter binoculars, which I mentioned are fairly common. A lot of people have them, but I find that list to be fun to do too, because they're fairly easy to find on star hopping if you're good at star hopping with charts. And so it's a fun project to for me to do. I'm not here to recommend that you do it, but if you do want a nice, easy project to do, it's a fun project. Dark nebulae. It's one I started this past summer, and you need a really, really darn good dark sky. And so I only started doing this because I've been going for each year, past 10 years or more, to Manitoulin Island, where I can find really good dark skies in September. And so dark nebulae. So I started to do a few of this list, and it's quite an interesting, fun challenge. Don't bother wasting your time doing it from your GTA area backyard. But this telescope I illustrated is a 5-inch Newtonian wide field. So a good wide field telescope does a good job on it. So carbon stars, another fun one. This is a list from the RASC handbook. I recently finished the Astronomical League's list of carbon stars too. So it's a fun list to work through, because they're interesting to find a star in your star field and see what's that really bright red or orange star. They really stand out in a lot of cases. So it's a fun little project to do. So I'm finishing off just about here with very interesting feature that's been appearing in the Observer's Handbook the past few years, or a bit more, called the feature star field. And this year's handbook has the area around Perseus. And so these authors, Chris Beckett and Randall Rosenfeld, do a pretty good job on listing a lot of interesting features in the area of this constellation. And so I decided in the past couple of years, these are really good things to work through. So some are really easy, and some are a bit more challenging. Some are easy naked eye type clusters and binocular clusters. Others are fainter galaxy nebulae that you have to really work at to find. But it's an interesting project to illustrate, which is I'm working on. So let's see. Final one, I wanted to finish off with this, because this is a really darn nice, fun list to work through. So I highly recommend it. So this is another photocopy from a page from the RASC handbook called Wide Field Wonders. And so I started working through this one last year as well. And so it's really fun, because each of those clusters that I work through, when you're at the right ascension range, and that means that if I was on, say, Manitoulin Island last September, and it means that the part of the sky that's in the evening sky might be 16 to 20 hour of right ascension range. So some objects are not in the sky all the time, but the half a dozen or so I picked, each one I looked at, I thought, wow, this is really darn nice. It's a really enjoyable thing to look at, these objects. So here I've illustrated a wide field pair of binoculars, 100 millimeter binoculars, but you don't need that. So I just want to illustrate it, but these are just really nice to do. So that's why I'm finishing off with this project. So I just mentioned there are some other projects to do besides all of what I've illustrated. I'm currently working on. There's asteroids, Sirius B, a double star Sirius B is an interesting challenge to look for, and there's Lunar 1000 challenge and a whole bunch of others. And all these resources here have more targets to look for in a telescope visually. So this is my future after I finish the current projects I'm working on. Okay, so just in summary, I just want to point out that the only summary to point out is this is an ongoing thing. I'm doing it every clear night that I have. So I'm going to keep an eye on the weather. Don't look at that weather chart in the lower left. It's not a very pretty one, because I picked a forecast chart for right now, and it's not a pretty thing to see a big low overhead. But you see the picture on the right shows daytime clear blue skies. So that's what I'm waiting for. So that's what we're going to do. That's what I'm going to watch for next clear night. And all of those things I've showed you in the slides are what I'm working on. So that's it. So thank you very much for your time.
Thank you very much, Frank. Any questions from the audience? Oh,
thanks, Frank. Shouldn't leave the audience with the impression that they have to have 23 different telescopes to embark on this.
No, it's a good point. It's a good point, because I should have said you can do most of these with one telescope, like say a common 8-inch Schmidt-Cassegrain could do a lot of these. It's not a wide field instrument. It's not a super high magnification or high aperture, but a simple 8-inch. I'd even recommend for most people an ideal telescope is a 5-inch. But you could use one telescope to do quite a lot of those for sure. What your question was?
Yeah, the question, just as a curiosity, because these lists or the certifications, there'll often be objects or targets that are common between the lists. Not all, but those collisions will happen. Just if you were putting in for two different certifications, both of which had the same object on them, would you do two separate observations, or would you submit the same observation?
So the answer to that is that the answer is doesn't happen on the RSC because just for one example, the Deep Sky Gems I mentioned, that's a list compiled by David Levy, and he chose ones that were not on the Messier list, not on the RSC list called Finest NGC. So he chose ones that were not on them, and there's many, many hundreds of others. So he compiled that list to be not excluding those ones. Yeah, so no collisions. It does happen with the Herschel 400, so there were some overlaps. But in a lot of cases, I decided to observe it anyway. And I'm re-observing, I mentioned the lunar targets, I'm re-observing them just because they're fun. So the answer to your question, there's very few, if any, exclusions. You have a question, Samuel?
Yeah. So, Frank, thanks a lot. Frank, how many telescopes have you made?
How many have I made? Probably half a dozen, but I'll admit, I used to think, my wife used to try to convince me to have too many telescopes. But really, all those telescopes I showed you have more, many more. I love them all. They're really fun to use, really enjoyable to use. And some are, as I mentioned, are ideal for planetary viewing. Some are ideal for wide field viewing. I'd have to tell you,
You made 6.
probably more, but I haven't tried to count them.
Did you buy the mirror or do you make them?
I've made some mirrors. I showed a couple. I showed you that big 12.5 inch. I made that one. The first one I showed you was the 8-inch f10. Well, let me tell you this. I'm not here to promote telescope making. That's a whole separate topic. But when you spend many hours grinding and polishing the mirror and get the figure just right, and many hours testing the mirror and getting it just right, and then you think it's just right. That telescope is just right, and then you get it luminized and you put it in the telescope. The view through that telescope, it's just phenomenal compared to any other telescope. It just feels so nice because all the hours are put into making it just the right perfect figure. And so it means that when you look at a really high definition target like a planet, the view is phenomenal because it's my own little baby. So that's why I got off on a tangent, of course. But the answer to your question was, yes, I've made a few telescopes and I have bought a few too so I love them all. I love using them all. Talking to the mic, okay. Okay, I'm finished. Are there any other questions?
Any more questions from the audience?
What was the name of the website to track the eclipse times and the estimation of how it would look?
Denis and that, but timeanddate.org.
Oh, sorry.
Timeanddate.com.
Look up Toronto and they have a link to it.
Timeanddate.com.
Yeah, I was just wondering, for your solar observation, were you using a filter, or what type of filter were you using?
Yes, solar filter. So that's 80 millimeter refractor, and the filter was a Kendrick filter. So common commercial filter just snapped onto the end of that 80 millimeter refractor. So the 80 millimeter refractor is a really handy little telescope. I use that for the Venus sketches that I showed too, but it's just simply snaps on to the end of the tube. So common commercial filter, that's what I used.
Well, you've mentioned that a lot of your projects were fun. So in your opinion, which of those lists would you describe as most fun?
Very good question. The most fun list is the one called, what was it called? What did I call it? Wide Field Wonders? Yes, Wide Field Wonders. This is the one that's the most fun. And this is one I recommend everybody ought to do if you have a telescope and you're looking for something to look at. I found this to be, from my personal situation, the most enjoyable fun, because all the objects I've looked at on it are really neat. And so I look at them, each one, and I think, wow, that's a really beautiful site. And it's fairly easy to find in a lot of cases. They're not like really faint fuzz patches that you have to search around and be sure if you're looking at it or not. So this one called Wide Field Wonders is my favorite. Okay.
And we've got some questions online.
Actually, not questions, but a few comments. Eric Briggs says, thanks for describing that truss tube telescope. Fender 90s says, can't wait for the warmer days to come so I can get out more. Unfortunately, I don't have access to the sky from my apartment in downtown, so my DSO setup with a mono camera has been sitting around for some time. I thought you might want to give him some advice.
Sure. Great question, because a lot of these targets that I've chosen can be viewed from the city, from any urban light polluted area, including where I live, although it's not as bad as some other people's areas. But double stars, the carbon stars, and open clusters are excellent, and the planets are excellent targets for an urban environment where you don't need a dark sky. Lunar for sure, yep. Good point. Lunar and solar and planets. Basically solar system, and this one called Wide Field Wonders, and double stars and carbon stars and open clusters.
All right. Any more questions from the audience? No? Okay. Frank, thank you very much. And we're going to go to fun facts while we set up for our last presentation of the evening. All right, and our final presentation of the evening, Jeff Booth and Tony Horvatin will be talking about Aurora Borealis, a mesmerizing natural wonder. Jeff?
Well, thank you very much, Tom. Good evening, everyone. obviously, I'm Jeff. Tony will be up in a short while. As Tom introduced, we're going to be talking about the Aurora Borealis, a mesmerizing natural wonder. In 1619, after looking up at the northern sky and seeing green, red veils moving around, Galileo Galilei coined the term Aurora Borealis. He was filled with wonder. How many people here have seen an aurora? Put your hands up. Oh, wow. Oh, that's impressive. Well, members of council, members of Toronto Centre, in particular, very welcome guests, and everyone out there in the World Wide Web. If you have seen an aurora, like Galileo, you will know how special that experience is. This photograph was taken from the north deck of your ECCAR Astronomical Observatory in early August 2019. Not bad. What do you think? Pretty good? Yeah, pretty good. Okay, so this is a pretty decent photograph of the aurora. But, you give me a thumbs up. Thank you very much, young man. But this is what four of us saw from that very same north deck May 10th last year. This picture was taken by Tony Horvatin, who will be presenting in a short while, and it images a vast swath of sky. It's 180 degrees from left to right. The left border of this picture is the west. The east border is the east. It's almost to the zenith, almost to the top of the sky, to you new people. That handsome fellow in the bottom left corner is someone you may know. Now, the bottom left corner as well, there's a little white light in the violet sky. That actually is an 11% illuminated moon. Now that name, Aurora Borealis, Galileo named it Aurora after the Roman goddess of the dawn, and Borealis after Boreas, the Greek god of the cold north wind. Looks like he's running away from her, doesn't it? Auroras happen all the time, and the closer you are to the north and south magnetic poles, the better your chances of experiencing an aurora will be. So let's return to that May 10th display last year. What's the story behind that? Well, it all starts here on your sun, about 150 million kilometers from us. A geomagnetic storm is behind every aurora. Rather than the calm before the storm, an aurora is actually the light show after the storm in space. This solar image was taken at the CAO about 4 hours before that remarkable display presented itself to us. Responsible for the aurora that we saw is that large active region in the lower right area of the sun, that vast active region of sunspots. By width, it's about 15 times the width of the Earth. Now, some context to that historic significance referenced a few seconds ago. 4 of us were at the ECCAR Astronomical Observatory last May around the same time as that immense region of the sun that you're now familiar with was particularly active. While we were there, we had a superb display of the Aurora Borealis, the northern lights all around us. Well, it now turns out that that aurora display that we 4 were lucky enough, so lucky enough to witness, has been adjudged the most intense display since 2003 at this latitude. At other latitudes that are closer to the equator, it's still being assessed. That display may have been the most spectacular in the past 500 years. We had heard reports and seen photos from Europe about an aurora display that was going on in Europe. Some of you will know is 5 or 6 or 7 hours ahead of us. So we began watching the northern sky. Tony running in and out. telling us what's happening and what's not happening. Well, the aurora showed up, I think, in Tony's first photographs, he's shaking his head, yes, as a strange marbling before it really became evident to your naked eye. Ultimately, this display produced aurora at far more equatorial latitudes than usual in both, as English is my second language, as usual in both the northern and southern hemispheres. This is where the context of the 500 years comes in, the equatorial context. In North America, aurora were seen across Canada, across the United States, as far south as the Florida Keys, as well as the Yucatan Peninsula in Mexico, the Bahamas, Jamaica, Puerto Rico, even seen in Hawaii. In Europe, this display was seen as far south as Portugal, Spain, Sardinia. And if you're in North Africa, in Algeria, and look north across the Mediterranean, this is what you would have seen. People in Algeria saw it. There's Algeria for you. Not to be too northern centric, let's go to the French territory of New Caledonia in the southern hemisphere, northeast of Australia, looking south to Aurora Australis. This is what was seen. This picture was taken by a gentleman called Frederick Desmoulins, and this is where he took the picture from. He was so excited at his Aurora Australis picture, he opined, "I have rarely been so happy when taking a photo. I could see the red color of the auroras with my naked eye." Well, he was backed up in that opinion by none other than the New Caledonian Astronomy Society, who said these photos were a first for that French territory. A first. Now, if there's a display in the northern hemisphere, there is an equal display in the southern hemisphere. It's just the way it works. What you're seeing here is a satellite image of the Aurora Australis going around Antarctica. And you can see Australia to the top left corner. A few minutes ago, I referenced a remarkable series of eruptions on the sun surface 2 days before we saw the aurora here. Well, this is a NASA video. It's an 8-second video of the sun on May 8th. If you look at that area below center, that is where all those eruptions happened. So this is an 8-second video, and it represents several hours of solar activity. We're going to watch this 8-second video, and then it's going to replay slower. See if you can see those eruptions. See if you can see those eruptions which sent huge streams of charged particles towards our Earth. See them? Those flashy things? That's them. So those coronal mass eruptions sent huge streams of charged particles towards our Earth. Here are a couple of opinions from solar scientists at NASA. Dr. Elizabeth McDonald, the coronal mass ejections all arrived largely at once, and the conditions were just right to create a historic storm. Another scientist, Dr. Teresa Neves Chinchilla, opines, we'll be studying this event for years. Now, again, you know all those charged particles came charging towards Earth. That's called the solar wind. Here's a brief NASA video of a generic solar wind in action. See all that stuff going out? And here's some more explanation with audio of the solar wind and its charged particles and how they react, how the particles react when they come to the Earth and to our protective magnetic field.
Solar rays, but it also traps some of the electrified particles in space around Earth. sun does not always send the same amount of energy. Sometimes the sun has a huge convergence of blast, more substance space than the usual solar wind. These events are called solar storms.
Solar storm.
During one kind of solar storm called a coronal mass ejection, the sun bursts.
A coronal mass ejection. See how large it is.
Sends particles of energy zooming through space. When a solar storm reaches Earth, it dances with our magnetic field. And some of the energy particles zip around the magnetic field.
You see how some of those particles are being trapped in the Earth's magnetic poles and being sent to the north and south pole, south magnetic pole.
Interactions result in displays of light in the sky. Aurora.
So what she said there at the end was that when the particles come into the atmosphere, they react with certain elements in our sky and produce an aurora. Now, what's an aurora exactly? You know there's different colors. So the solar wind's charged particles interact with Earth's magnetic field, traps these particles, and these particles react with the gases in our atmosphere. What happens is the gases become excited by the energy in those charged particles, and the various gases at various altitudes eventually want to release that energy, and it releases the energy as a form of light, well, as light. And depending on the gas involved, it's going to be a particular frequency of light. In other words, it's going to be a particular color. This is how we get the colors of the Aurora Borealis. Altitude is part of the equation here, ladies and gentlemen. At 240 kilometers and above, excited atomic oxygen produces red. It's worth noting that red is seen when the solar storm is really quite severe. So you don't see it a lot. But last May 10th, from the Carr Observatory, someone took this picture looking north. Whoop! Look at all that red in the sky. Look at that aurora. Red everywhere. How do you get green? Green and red, by the way, are the most common colors. Green's, I think, the most common color. Well, at an altitude of about 120 to 240 kilometers, you get excited atomic oxygen. You get green light here because of the higher concentration of oxygen at these altitudes. Here is a photograph of this green light. Interestingly enough, this is looking straight up. The aurora is above your head. This is called a coronal crown, a coronal aurora. This is the rarest kind of aurora. Look at that. The building, of course, is the residence at the Carr Observatory. Yeah, wow. This we had so many wows. One of us ran out of superlatives and started using profanities, which with discussing it with a friend who's a practicing psychologist, he said, "Oh, that's quite normal. It's just the way we work." At 100 kilometers and higher, you'll see violet. 100 kilometers and lower, you'll see blue. Again, these two colors are associated with really, really intense solar activity. So when we had that storm on May 10th, which was really quite severe, we had all of these colors. So let's have a look at these colors. Did we see them at the CAO? Sure as heck did. That's looking east off that north deck. Look at that. Absolutely spectacular. We had every color, we had every motion, we had every type of things moving above us. Yes, it's pretty, but sometimes there are problems. For example, in the Midwest, especially in the US, this solar storm interrupted some radio frequencies that are associated with GPS used in serious agriculture. And as a result, some very large agricultural operations that run their machines with GPS had to shut down operations for several days. Now, we got off fairly easy last year because some of you in this room may be old enough to remember that in 1989, the Hydro-Quebec power grid was taken down by one of these CMEs. Most of Quebec was in a blackout for 9 hours, affecting millions of Canadians. Now, on that happy note, it'd be probably a good time for me to change and invite Tony up here to continue with another part of the presentation. All right. Well, there you are.
Well, thank you very much, Jeff, for that presentation on the Aurora. You had a lot of fun there describing a lot of the science. I'm going to take a little bit of time now and show you some of the pretty pictures that were taken at not only at the CAO in this event, but in other events by our members over the last few years. There will be some data because invariably whenever you talk about pictures or videos that people take in astronomy, people always want to know what are the exposures, what lenses did you use, what camera, yada, yada. So we do have some of that information for you as well. So there are 5 time lapses, I'll tell you right away, that were prepared. Jeff did all but one of them, the first one, from data from various people. So thank you very much, Jeff, for doing the processing on those. And after that will be followed by an album of various still images. So the first time lapse we're going to look at is by Elaine Dos Santos. And Elaine traveled to the small hamlet of Hillsburg, which is about southwest of Orangeville, Ontario, back on October 10th of last year to take her images. And she used a Nikon camera with a 2.8 lens at 14 millimeter. Now that's important because the 14 millimeter gives a certain size of about 115 degrees corner to corner. And the images that Jeff talked about, and most of the ones you'll see are 180 degrees corner to corner because they were 8 millimeter. Now the ISO 1600 is important too, and we'll talk about that in a sec. But here is Elaine's video. So this video is 24 seconds long, but it's actually a 20-minute aurora. And why that's important is because Elaine took many, many photos to get this 20-minute aurora, but it's compressed into just 24 seconds. So what I want you to note there, I'll just play it again now so you can see that. If I'm allowed to, let's see. No, I can't without the mouse. So Jeff, if you just don't mind, just let's play that one again. Oh, and just go forward again. Okay, that's great. So what I want you to notice is how quickly the shapes change as they step through the various frames of the video. And why that's important is if you're going to set up a time lapse doing this in the future, you want to be able to manage the length of each exposure and what's the balance, I suppose, of the aperture and the ISO. And that'll come clear in the next video, but just want you to notice that one is fairly rapid. So the next one we're going to show you is of the coronal aurora that Jeff introduced as very rare, and that's the one that's up overhead. And so this was shot with a Canon T5i and an 8 millimeter lens, but this one was 15-second exposures, and Elaine's were very short at 2 seconds. So you'll see the difference now. This is processed into a 93-second video, and let's have a look. All right, again, so you see the different colors that Jeff was talking about, but when it's auroral and it's overhead, there is a different perspective. You're looking up from underneath at the aurora instead of looking at it to the horizon from the side. And we'll talk a little bit about that in the slides coming up. Of course, you can see the residence to the left there, and our little microwave dish, and the little blue light is just a pilot light on the dish, showing that our Wi-Fi is enabled. And it's just about finishing now. And you'll see how it's changing in the center and then how the color is changing. So what's happening is the areas of the atmosphere that are being excited are varying in the altitude as the energy streams down towards the surface of the Earth. So you see the difference between this video and Elaine's. The truth be told, this is kind of a mistake because I should not, by any sense of allowance. I should never have shot 15-second long exposures, because what it did is it blended all of the motion into one smooth motion, but at the same time it slurred the specific patterns that were there. But it does make a smoother video. So the reason why it was a boo-boo is because, as Jeff noted at the beginning of this, when I started taking pictures, it was barely after sunset, and we were waiting for it to get dark. So I was taking these pictures, these test pictures of the northern horizon to see if the aurora was visible. And I did see this marbling in the viewfinder afterwards, and I just forgot to change the ISO. So you have to be cognizant of these things as you're going along. There's a lot to manage. All right, so the third one we're going to look at here now is a video looking east. Similar, for the people who want to see the details, you can always freeze frame this later when it's published and put on the web, but the details are there. And here we go. So this was a little bit later on in the evening. It was when it was starting to dissipate. And so this is looking towards the east, towards Collingwood. And we still have lots of patterning that's happening here. These are mostly vertical rays. And we'll talk a little bit going forward at the end of this presentation. Well, at the end of my section, we'll talk a little bit about the different types of structures that there are in Aurora. There we are. Okay, and then I believe this is going to be number 4. So this is looking northwest. This one is now actual speed. It's only a 28-second video. And again, the tech details are there for those who are interested. So there's, again, our friend Jeffrey down in the lower corner there, tending to his camera. And the light you see down in the distance, that's the lights of Thornbury on the shore of Georgian Bay. And of course, the crescent moon is that white orb hovering there in the northwest.
Tony, while you have that up, I'm noticing in every one there's these little green dots.
Oh, there's going to be some noise. Yeah, it could be noise. The problem though is, and there'll be a slide coming to address that. So let's see if I don't remember, then just flag me out on where there's some processing is mentioned. Okay, so this is the last one looking north, and this is imagery now by Jeff Booth. 28 seconds, actual speed. So what you're seeing here is mostly rays, and there is some arc. And in a moment, we're going to talk about some of the different structures that are commonly found in auroral displays. And this has to do with the way the particles are streaming down and hitting the atmosphere as they are inbound from the sun. All right, and it looks like we have one more video. Sorry, this is the 5th one, looking northwest. So it was quite, as Jeff mentioned, I'll just take this moment to sort of editorialize a little bit. It was very striking when this first happened. We just could not believe it. We thought, oh yeah, we'll drive up north, see what happens. You know, we had seen all these reports in France that there were all these great aurora, but they're often fleeting. So you don't know if it's going to be, 4 hours from now, it's going to be over, right? What's the point? Why would you bother going? But we said, we'll try, see what happens. And so this is why we were so shocked and overjoyed, and using colorful metaphors in terms of describing what we were seeing. A little nod to Spock there, right? Yes. Okay, so, and another nod here, and I have to salute Frank for highlighting the Observer's Handbook, which is the I guess you would call it the unofficial Bible of the RASC. It's produced every year, and it comes free with your membership. This page is lifted from page 188 of the book, and it shows us hand sketches of the various common auroral forms. So the top section is homogeneous. The second section really is rayed. And then there's pulsating, and the bottom would be the irregular kind of glows. So we saw pretty well, I would say, I don't think we really saw flames in this one. We didn't see anything that was pulsating the way that it's expected. I did see I have seen spot pulsating in the past in other displays, but this display that I saw was the finest for sure in my astronomical career. How many people here were at Mew Lake Algonquin Park in September of 2001 and saw the display there? Yeah, okay, Dennis, you as well. And I know Grace, my wife at home who's watching, was also there. That display, for many years when I'm doing EPO and outreach and talking to people about astronomy, that display was in my top 2, maybe 3 astronomical experiences in my lifetime. So this one is sort of booted that one down the rung a little bit, but maybe why that one might have been better is because there were 200 people out on the grass in Mew Lake ready for an evening of observing with us astronomers. And all the astronomers are going, oh, grumble, grumble. Oh, it's not getting dark. It's not getting dark. What's happening here? You know, it's like, damn, you know, we got all the scopes set up and everything. And it became obvious there was this auroral display. And picture this, it's Algonquin Park, new moon weekend, no lights. I was able to walk along the beach, stepping over and around the people lying on the ground, looking up at the aurora. And I could clearly see the colors of their clothes and the expression on their face by the light of the aurora. That's how bright it was. That was just magical. So as you can see, these types of events can be very magical. So we should try and pay attention to try and find them. So now we're going to spend just a few minutes and look at some photos. All right, so this picture was taken by Richard Sewards, who has a cottage up in the Tobermory area, so he's very lucky to have access to these types of places. This was June 27th in 2024. He did this with a Nikon D7000, 16 millimeter lens. And the details are available on this if people would like. This was a 10-second shot at ISO 3200. All shots have been on tripods. You cannot handhold any of these things because of the long exposures. So this picture actually deserves special mention, also by Richard Sewards at Tobermory, but this one was published in Sky and Telescope. And so because at the lower left, you have Comet Pan-STARRS, the Andromeda Galaxy, and the Perseus double cluster. But this is a very fine picture. You would consider this an absolutely excellent aurora in normal times, really. So, all right. So this picture was by Claudio Oriani, who's often an EPO volunteer at the DDO. And he took this with his Samsung smartphone, a Galaxy S24, 1/4 second ISO 3200 with an f1.8 aperture, which means how big the lens was open or closed, and definitely on a tripod. Now, this was October 20th, 2024, the same night that Elaine dos Santos did her time lapse in Hillsburg. Another shot by Claudio in the same night, a little bit wider field, so you can see the dome on the admin building. And again, a Samsung smartphone. Now, these are processed a little bit. That's not right out of the camera, but with processing, you can enhance some of the definition and boost some of the colors. So all of these that you're seeing now have been slightly processed, but I'm going to show you some pictures towards the end that show you what is the difference between out of the camera and the final presented ones. Pardon me. All right, so this is a picture of the at the CAO. The University of Toronto has their own clamshell dome there, the Dunlap Institute for Astronomy and Astrophysics. And they were very happy to receive this picture that Jeff took, and it's posted there. And I believe they also use it in their astronomy summer course as well. Here's a shot of the coronal aurora. And again, it was just unbelievable. You can see the cloud bank in the east there over Collingwood that started moving in towards the end. But it was clear the whole duration pretty well until we got tired of watching it. Yeah. We didn't run out of film because, of course, you know, the skies. Oh, okay, now this is a special picture, and I'll make sure I mention it, Jeff. So what is that streak that you see through that green portion of corona? Anyone want hazard a guess? ISS, full marks. That's what it is. Yeah, that's the International Space Station. So what are the chances that you're here taking this picture, looking at the sky, and here's the ISS making a flyover? So the ISS, and Dennis did mention it earlier on, can be predicted when you can see it in the sky. It's very easy. It's very bright, and it proceeds very slowly and very methodically across the sky, always sort of from the northwest towards southeast. So this can be seen even in Toronto very easily. So it is worthwhile to try and look that up. There are many websites that can predict when you can see that. Yes, the crew of the ISS would see the aurora, but they're not looking up. They're looking down or across the globe. Yes, they would see the aurora. And there are many videos on the internet of the aurora from space. So for photographing the aurora, what to do? I'm not going to spend a lot of time here, but there's always people who are interested. And you should really be aware, because if you're caught someday out there and there's an aurora happening, you should have some kind of an idea of what to do. So there's a couple of tips that we can give you. And that is, generally, it has to be as dark as you can make it. You have to get away from the city, because the October 10 one, I couldn't get out of the city. I went to look at it from where I live in West Toronto. I couldn't see it. It was, yeah, you could see something moving, but there really was no definition. I even took pictures. Was not worth my time to do that. So you have to get out of the city, get a good northern horizon, because the poles, the magnetic poles, concentrate on the northern pole for us here in the northern hemisphere. So you want to look towards that direction generally. And when you're there and you get set up, you want to make sure that you protect your eyes from white light. We say have dark adaptation. So that means you want to stay away from white lights, including your cell phone. If you're going to be able to take an aurora that's showing on the northern horizon, move around and try and get different kinds of objects in your foreground, as Jeff did with the U of T dome or the house or the other modal observatories that are there, to give it some interest and some scale. And this is, I'll mention it here now, this is one reason why a lot of authorities on aurora photography don't like to go below f2.8, more or less, for your aperture, because what can happen is if you go too low, then it's very difficult to have enough depth of field to have your foreground object in focus as well as infinity of the aurora. So if you have it really wide open, you may not get a good sharp image of your foreground, because you really want to focus on infinity of the aurora. So as we mentioned, a tripod is an absolute must. You must have the tripod. Now, a remote shutter release is very handy. Brought this little doohickey in. We've talked about intervalometers. This is an intervalometer, and it plugs into the little port on the side of your camera. And what the intervalometer does is it can be programmed to set a series of pictures so that it takes a set length and then an interval of a wait as it downloads the image, and then another image, and you can even program it how many images you want it to take and so forth. Now, a lot of modern cameras have that built in, but a lot of cell phones don't. So that way you're allowed to take a string of multiple images that you can later use for processing to make a movie like you've seen here. Manual focus only, we say, because of course, if you have an automatic camera, it's sometimes what it does is it searches. It doesn't know, is it okay now, is it far or is it near? And we've all seen videos where it's very annoying that the focus is coming and going. So use manual focus only. A lens hood, which keeps the dew off sitting on the lens, because if you're out there a long time, your camera's going to get wet, and if a lens with dew on it is pretty well useless. Fast lens is what we say. Fast means low f numbers to within reason. And a wide field of view. Now, you notice that the the 8mm lenses that Jeff and I were using, both of them have a very distinct sort of arc on the bottom of the frame. So that is an artifact of those lenses, because they're a fisheye lens. They tend to warp the horizon. So it's kind of a trade-off. Do you want 180 degrees of sky in your picture? Well, then you're going to have an arc. Or do you want to have a 90-degree picture of the sky? So it's all a trade-off. So you have to consider those things. No filters on lenses, they say, because not only does it reduce the amount of light, but it can also introduce artifacts which are near impossible to remove. So this is the big and I'll point this out, this is the big hazard to do with any photography, and I sort of fell into it myself, is I was shooting at 200 ISO and long exposures of 15 seconds. If I had not noticed that or spoken with Jeff about that, I might have done that the whole evening in my jubilation and not noticed, right? So you have to be mindful of these things, what your settings are. And actually, this is a good time to confess. At the 2001 event in Mule Lake, I had my Olympus OM10 beautiful manual camera set up on the ground with a wide angle lens, and it was snapping exposures of this display that I described to you. When I got home, I found out, so much to my dismay, of course at that time it was on Ektachrome because I didn't have a digital camera back in 2001, I had inadvertently in the dark stopped the lens down to f32. So my friend Dave Sage tried so hard to try and recover images, but yeah, no. So just saying, you know, it's not for the faint of heart. Anyway, so exposure. So here we talk about exposures, and I won't spend a lot of time of this. People want to dissect what's happening here. Again, review the video when it's online. It'll be posted up in not too long. I'm sure our team will be working on that, and it'll be permanently on our RaskTO YouTube channel. So typically, this is what we suggest people do, this kind of a regime. And ISO is important too as well. Dennis, you have a question, sir? Yeah. How do you get that kind of result on the screen? What are you referring to? Oh, you're not nice. Assess your result on the screen. No, he's just being silly. That's fine. I get it. We want to assess the result on the screen. Yes, thank you, Dennis. Okay, so, and last couple of items is you want to dim your screen if possible. A lot of cameras allow you to have a red background color on your display screen. So of course the usual things, have extra camera batteries and so forth. Dress properly. Make sure you have the right cables too with you. It's happened several times when I've been at the CAO as supervisor. A member has come and said, I'm out of luck. I forgot to bring this mini USB cable. I can't do anything. I said, no problem. We have some here. Here, borrow it. No problem, right? So make sure you have all your gear, because it happens all the time. People come and they're missing that one piece of equipment that's going to scupper them. All right, so processing very quickly now, 2 quick examples here. On the left, you see what comes out of the camera, 15 seconds at ISO 200. And on the right, this is what Jeff did to boost it up to get definition out of it and show what are the true colors. I mean, the green is not even visible really in the left shot, but it is brought out in the processed unit. And this is very much to taste. As he indicates there, you can do this up and down to whatever endpoint you think looks normal. And here's another shot as well as the same, what processing can do. Now, you're going to ask, what did you actually see if this is what the camera saw? Well, I can tell you it was very much in between those two, very much in between. It was certainly not as bright and vivid as the processed, but it was a heck of a lot more pronounced than the original one that the camera recorded here in that particular exposure. And with that, I will turn the floor back to Jeff.
We'll have a question period in a few minutes. Thank you very much, Tony. I have heard of people being so excited they left the lens cap on their camera. That's never fun. So if you want to go chase an aurora, how can you forecast one? Well, the sun has a roughly 11-year solar cycle, and we're pretty well at the peak of it right now, and it's going to end, we expect, around July. Might go on for a few more months, and then it's going to slowly taper off. So what does that mean for chasing an aurora? Lots and lots of potential opportunities coming up. So fingers crossed, everyone, fingers crossed. The most common predictor for whether there's going to be an aurora or not is something called the KP index. It describes the disturbance of the Earth's magnetic field caused by that solar wind that you saw coming in. The faster the solar wind blows, the higher the KP index is going to be. The KP index will go all the way up to 9. and we had 9+, I think, last May. So this stuff is easy to find on the internet, and we're going to give you a page of links towards the end here. This is a quick chart of aurora activity tied to the KP index number at KP0. It's very quiet. Things are basically pretty boring, but up at KP9 down in the lower right corner, you've got everything going for you, including free pizza. No, not free pizza. The National Oceanic and Atmospheric Administration in the States has a great website that has all sorts of aurora predictor graphics. This is just one of them. Expressed another way, here is North America with the blue line is a predicted KP3 aurora. You see how far it goes down south, just to the south end of James Bay. But if you look at the KP9, it goes all the way down to the Carolinas. So that stuff's out there, and as I said, we're going to have a page of links at the end of this, and if you guys want it, I'll post that page of links to the forum. Now, one of the controversial things for years about Aurora Borealis is, are there sounds associated with them? It's been controversial because there's been no hard evidence for it. I used to live in the mid-north, northwest of Sudbury, and I walked into town one day, 600 population, so pretty dark. We had a spectacular aurora display, and I could hear, no one's going to throw something at me, I hope. I could hear a buzzing, like a 60 cycle hum, like a fluorescent tube that was starting to go somewhere up here. My buddy and I both heard it. My dentist, who used to practice in the far north, told me one day he heard it too, but he never spoke to anyone because he thought they would laugh at him about it. Well, guess what? Some scientists in the Finnish village of Fiskars recently set up some sound equipment, and guess what they found? They found that there are sounds associated with about 5% of the strongest auroras. And these sounds seem to happen only when there is a temperature inversion, where there's a cold air cell trapped under a warm air cell. And these sounds seem to happen at the interface. So here's a quote from Unko Lane, who wrote the research paper on this. Sounds associated with Aurora Borealis, so-called auroral sounds, are explained by electrical discharges occurring in the temperature inversion layer approximately 75 meters above the ground. So you're looking at the aurora 100, 150 miles up, 240 kilometers up, but you're listening to it 75 meters up. That's why you get both of them. So as we're moving to the close here, let's enjoy some cherries on this cake. Some aurora factoids. We talked about Galileo Galilei naming the Aurora Borealis. Who named the other one? Captain James Cook in the 1770s, his voyage to the Antarctic in the vessel Resolution, saw the aurora down there, and he called them the Aurora Australis, with Australis derived from the Latin word meaning southern. Norwegian professor Kristen Birkeland was the very first scientist in the world to realize that the northern lights had something to do with electromagnetic storms coming from the sun. And Norway has honored him by putting him on their 200 kroner note. On the back of that 200 kroner note, there's a graphic associated with this professor's work. Now, this is around the turn of the 1800s to the 1900s. Let's go back a lot more, 30,000 years. This is a Cro-Magnon cave painting. It's thought to possibly be the earliest depiction of an aurora. It dates to 30,000 BC. I didn't pull this off of some crazy conspiracy website. I got this from NASA. Are there auroras on other planets? How about you future astronomers and future scientists? What do you think? Yeah. Oh, well, okay, you're moving into postdoctorate in about 2 weeks, okay? Yes, there are. Auroras occur in other planets. Jupiter, this is a Jupiter picture. Saturn, Uranus, Neptune, Mars, and similar to Earth's auroral experience, these lights have been seen close to those other planets' magnetic poles. So in summary, if you want to experience an aurora display, Remember, solar max continues for many more months. Monitor the KP index. As Tony says, get to dark site. Observe dark adaptation protocols. Stay away from white lights and stay away from a bright cell phone screen. If you're taking photos, test your images to find the setting that works best for you. So, ladies and gentlemen, future scientists, it's been a pleasure and an honor being here for you. We thank you, and these are the 4 that were there. That's Tony, Terry, Jean, and Jeff. And I wish they were here, but if you guys are online, thanks very much. Time for questions.
All right. So, first of all, I have the mic, so I'm gonna make a comment. I apologize to this wonderful presentation, but it is possible if you're lucky enough with a good enough cell phone camera, if it's all you've got in your hand at the time when it happens, to do a few things. Some of the more modern ones, you don't even need a tripod. Literally, just hold as tight as your arms as long as you can for about the 4 seconds that this thing will try to take, and then the onboard software will do a little magic, and you will get some results. May not be as good as what the gentlemen here have shown you, but again, if it's all you have, if you find yourself, if you're driving out in the countryside one evening and all of a sudden the sky goes nuts, your cell phone camera can do a few things. Okay, so
yes, you're absolutely right, Tom, and I agree with that. Brace yourself if you can on a railing or a tree or the side of a building or something like that, but always try. There's no harm in trying anyway.
Question. When's the next one? Oh, Tony, that's your question.
I'm not sure if it's beyond the scope of a lecture on the Aurora Borealis, but I was curious how the Aurora Borealis and capturing the Aurora Borealis might differ from like the Steve phenomenon, or if the Steve phenomenon is ever visible in North America or Canada.
My understanding is Steve has been photographed in Canada, but to my layman's. Oh, I'm sorry. I understand Steve has been imaged in northern Canada, but to my layman's understanding, it's a very fleeting thing. The Aurora Borealis is fleeting as well, but relatively speaking, Steve is much more fleeting. So this was the best Aurora I've seen in my life, and I live in the mid-north. So how many lifetimes will I have to live before I see a Steve? That's the best I can give you. Thank you. Good question.
Okay, any other questions?
Steve is another.
Use the microphone, please, for the people at home.
I
So
can-
the
I'm not
the question is, what is a Steve?
I am not an astronomer, but my general understanding is it is a phenomenon somewhat similar to the Aurora Borealis, but it's like streaks, and they call it Steve in some kind of it's an acronym, yes, where they just decided to call it Steve and then made an acronym to like fit the letters. But it is still based kind of in the same way, but it's streaky. It's not like the fun, flowy lines. It doesn't last as long.
Okay.
When Tony presents the post-grad lecture on this, he'll talk about the Steves.
Okay, seeing no more questions in the room. Any questions online?
A couple of comments.
Grace Horvatin had a comment. Stunning.
Gee, thanks, Grace. I think she's referring to Jeff's part of the program, though, clearly.
And Wonders of the Sky, which is Claudio, said, love your mention of Greek mythology, Jeff.
Glad to present your stuff as well, Claudio. Your photography is magical, and I wish we could see more of it. And I know you do present, but we look forward to seeing more of that. Thanks.
Claudio, thank you very much. And I should give some context to the audience here about Claudio's comment here. Claudio lives part of his life in the ancient world and presents on it. So Claudio, when you want to present an archaeoastronomy, we really look forward to it.
All right. Okay, that looks like it for the questions. Gentlemen, thank you very much.
Thank you.
And that concludes the presentations for the evening. We're just going to have a quick flip over to fun facts while we get the announcements up for the end of the show. All right, ladies and gentlemen, and to conclude our evening, President Scott Masterton with the announcements.
Thank you, Tom. And thank you, everyone, for tuning in. So today we have announcements, and I want to welcome you to the RAN, or the Recreational Astronomy Night, which we had a while tonight, and we will have speakers in another couple of weeks. And oh yes, you can use the chat function to introduce yourself and ask questions. So next speakers night is March 19th, 7:30. It's online only because our speakers tune in from various locations. And this will be an educational guide to, oh, I'm sorry, it's Alex Jude here at the York University. And it's an educational guide to the Quail Telescope. And you can get information on that at the indicated URL. The Carswell Observatory has tours every Wednesday evening. We had one tonight, and you may come here between 5:30 and 7:30. Well, our talk starts at 7:30, so get here early. You have to sign in to get tickets, and the indicated URL is there. But if you go to our site, you can get that information from the events page. DDO Space Action, Craters and Comets, March 8th, during March break. and learn about comet composition, impact craters, and the information is there. It's suggested for 5 to 12-year-olds. March break, again, March 15th at the DDO, learn about the sun and practice safe solar viewing. And the information is there again at arasto.ca, and on the events page, you can get information there in order to sign up. Out of this world at the DDO, solar system, date and time, March 12th. And again, a description of March break at the Richmond Hill DDO, and it's an in-person event. Tour the solar system and learn about each planet. The DDO Sun Fun, we have quite a few programs during March break. On the 15th, between 10 a.m. and noon at the DDO, and it's a you're going to practice safe solar viewing, right? The fees are indicated. So again, astronomy, a family night, constellations that evening, 7 to 9. A description of families. We'll see. The description is families will see a presentation on a variety of astronomy topics. I'm sure it's suitable for kids and older children. Sunday virtual sun gazing on March 30th. Well, we're going a bit in the future, but again, at the DDO, we have all these events that you'll find very interesting. And there we are. Astronomy Speakers Night, March 22nd at 8:30 at the DDO. Dr. John Moore of the York University. His topic is Daydreaming in the Solar System, Exploring the Planets with Our 5 Senses. And again, the information to sign up is there on the page or on our recreational event page. DDO in person, March 30. We're getting further in the future, but again, we have a Sunday sun gazing event. Planetarium Day, that's in May. Well, that's a bit early. We'll announce that later. Oh, and the I wanted to let you know about the Carr Astronomical Observatory, or the CAO. This is our observatory property with a roll-off roof observatory for members, and you're encouraged to join. And if you'd like to take advantage of the dark skies at our Carr Astronomical Observatory, you may do that. And this is just to give you a little teaser. The roll-off roof observatory here, this is with the roof closed, and this is the viewing area. And that's our telescope, and you may be able to have a look, provided the supervisors make that available and the weather cooperates. And this is the control room. So it's really an upper level observing experience. And of course, we like to let you know that we need volunteers, and in order to be a volunteer, you need to be a member. But if you're interested in helping, please let us know. Contact the volunteer coordinator. And of course, we need membership to do that. So you may join our organization at the national office, mempub at rsc.ca. Have a good night. Oh, and you should consider joining us afterward. Oh, I didn't get that, Matt. Anyway, we have, what is it? We can go to a local restaurant, VMV's, at 4207 Keel Street, which is just 2 blocks south of the east entrance to York University on the east side. The big sign, the side of the wall of the building has a huge VMV sign, and it's free parking. So if you're so inclined, please join us there. Thank you very much.